Hello and welcome. I'm Bill Wake. I'm a consultant working on software for various things, and what we've been working on lately is an Elm interpreter written in Swift. We've handled number literals, both floating point and integer, and we handled end of line comments and spaces and new lines, but we haven't dealt with nestable comments that have end of file in them. So we've done the bulk of nestable comments, but not that. Let's fix this and go over to the IDE. All right, so nestable comments, they're brace dash, and if they're nested, they have another brace dash inside with a comment and a dash brace, dash brace. The concern we have, and I think we touched on it just at the end the other day, if you were to end your file, so you opened up the two and then after the word comment, you just had end of file, we don't handle that well. So we need to make sure that that gets detected and ideally at least reported as some sort of error. You're not allowed to close them off this way. Unlike end of line comments where if the line ending is the file ending, that's okay. But this one, you've committed to closing your braces. All right, I ran the test, so we're green there. And let's go down to lexer. Okay, so we've got our private, we've got our nestable comments. We're using recursion here. Nestable comments contain nestable comments. So this is more recursive descent and not regular expression. Where the whole rest of our lexical analyzer was regular expressions, we've put a little bit of recursive descent in here just for this one token type that can be nested so much. Now, if we have the notion of returning token.error, but notice we are looking for things. If we don't find the dash, that means there's a problem there. So we want to deal with that. But if we hit end of file, this should give us a problem too. And same thing anywhere in here where we're looking for it. It's really this loop, characters not dash and characters not a brace. We just say input next character, and if it's end of file, we treat that as a character and keep getting it and get an infinite loop. So let's find our test. All right, unterminated comment returns error. All right, so we have check tokens. Well, I guess we just need check token in this case because there's only going to be one token. And if you start a string and I don't know if it's nested or not. Well, let's deal with the first case first. Let's go with this. So in effect, we have our end of file at the end of this string. And we expect a token error at this point. Okay, so you opened a brace and you just forgot to close it. Not good. All right, this test should fail. Actually, I think it'll fail by running into an infinite loop as it continues seeing error characters or the end of file character in that loop. Okay, so in general for us, any loop that might get an end of file in it, and we need to be aware of it and deal with it. Okay, so let's lock this in. All right, whoops. Can I aim? All right, there we go. Okay, so we see we're testing, and well, it's taken this long to start up before, no doubt, but in this case, it's not that. It's really here. The character is not a dash. It's not a brace. That's true because it's an end of file. Okay, so let's stop this test. And this is not a great way to end. I mean, a great way to detect these things, but that's where we're going. Okay, so the places I'm looking for places that get, well, really it's these while loops. Okay, so a while not equal is the worst because any end of file could come up. Okay, so we're going to have to say and character is not equal to, and we're looking for, what do we call it? My input dot end of file. Okay. So if it's not a dash and it's not a brace, and it's not an end of file, then we're going to consume it. So this is just eating the characters that are in a comment that we don't care about. And so we're going to keep rolling along. Okay, now if the character is an input, okay, now we know we have a problem, and we're going to return token.error. Okay. Now this does not handle our nesting because we just ignore the token.error, but we'll actually it might handle it because it does loop back around. But let's run our tests again. Okay, so launching and testing. All right, yeah, that's nice. Okay, so not hard to do, but we couldn't do it in the last 5 minutes last time. This exits, so while it's trying to eat stuff, okay, notice we've got the brace. We assume we have that. If we don't see a dash, it's an error already, and we're out. But it's this while loop that's potentially problematic. We fixed that. Okay, now we got this. If the thing is a brace, then it may be nested, and we're going to have an issue there. Now this while is okay. Okay. We're only looking for dashes, so there's no harm in that. Eventually, if we hit end of file, we hit a non-dash. Okay. Now this one, character is not equal to brace. It puts us back up here, and we would see that end of file again. So the place I'm a little worried is the nested one. I think what's going to happen is it returns token.error on the inside and ignores that. And maybe it'll come back around again. We'll test it. Okay. And let's just copy this for starters. Unternated nested comment returns error. So if we did this like that, I think we should see an error, I guess. I hope we will. I believe we will. I'm not totally certain. How's that for wishy-washy? Okay, good. So we did handle that again. I think because even though we ignored it here, we come back around and we hit it. So the outer loop detects the end of file, and that's fine. Okay, let's commit this. All right. Okay. All right. Let's see. So our to-do list, that's where we want to go. All right. So this is the story is ignore nestable comments today. And a file inside nested comments. Yes. Okay. Now, all right. The other thing I want to do today, I should say, we'll get into file comments. They're basically done. I've got some cleanup I want to do in the token, the lexical analyzer, and then I want to tackle Booleans, and we'll take a look at that shortly. But, well, I guess a quick look now. There's a type built in called bool, has two values, true and false, and they act as if they were defined by the system, which let's find one of those. Custom types. Yeah. So as if there's a type Boolean equals true or false, and Boolean operations on it defined and all that stuff. It's a very low level type, so the manipulation of it is not really done in the language. It appears to be done kind of right at the cusp of the JavaScript / Elm barrier, I guess I'd say. So anyway, we'll assume the type exists, and we'll get these constants going. Once we have those, I'm bouncing around a little bit, but I would like to do ifs. So let's find conditionals. You know, if I have a Boolean, I can do this and return one of my values I already have. So I want to get a little bit more sophisticated language side. We might want to define these custom types, though. That could be an interesting path. I'm not clear about the capitalization rules, but we'll deal with that. Okay. So we've done the end of file, but let's look at our lexer. All right. The token type is the result types that we have. Eventually, those will need like line numbers and file names and whatnot, column numbers. There's a construct that uses the column number, so we'll have an incident to put it in then anyway. We got a method get, and then each one of these, let's see, open this one up. So get looks at the front character, which is already preceded. Get that here. So we read the first character when we get going. And then get handles, basically it's a big switch statement on each character. And if it sees spaces, new lines, dash, part of dash comments, braces, part of nestable comments, or digits, it knows it's starting a new token. And then each one of those gets its own method. This could probably be, let's clean this up. I have a grammar somewhere. Next page. Okay. I think, yeah, this is pretty much right. Whoops. Basically dash, brace dash, anything or nestable comments repeated and brace dash. Okay. And that's the recursion in there. All right, let's put that comment in instead of this junk. All right. Okay, and I think our code reflects that reasonably. We may... There's some duplication. But I think we'll let it go. Okay. Then the other thing that we saw in here was this number string here. This, as we're as we get digits for a number, we're going to accumulate them somewhere so we can interpret the number. And I would like to have this thing managed outside of this method and just be a generic thing that as you accumulate stuff, you put it in this buffer and then you can get the word that corresponds to it. As we get to Boolean true and false, we're going to need that again, so it's clear it's a broader need. Okay, so let's see what we can call it. Maybe it's token body. We'll go with element. I don't know if I used token enough yet. I got capital T token. I guess I can use lowercase token. So let's do that. Rather than, we'll rename this to token. Okay. And just to make sure nothing's too crazy. All right, and I'm going to migrate this up. We don't have a built-in refactoring for it, but I'm going to move it from private scope of a function up to public, well, semi-public, up to the class level so we can get to it here. Okay, and this should change. Well, it really needs to be initialized in our loop. Okay, so let's initialize it here. Okay. And with that, we don't need it initialized. Well, there's no harm in it. It's got to be initialized one way or the other, so we'll just leave it initialized there. But the key thing is when we go through our loop, we want to reset it each time. Okay. This should also pass. Now I don't need to track characters for every possible token, just the ones I care about their contents. So numbers I care. I gotta wrap up that number and put it in either an int or a double. All right. Yeah. Now I'm desiring that I could get rid of that these things could do their job. I mean, kind of like this. While this contains it, I would like one that's kind of a skip while or skip until. Yeah, maybe it's skip until. Okay. Let's see. So we got this while. Let's see what whiles we have that are like that. Here's one. Okay, so let's try and extract this. I'm gonna make. Well, I almost want to just make a set of these characters, right? I'll just say, I don't have a better name, but let ending equal a set of, and then I can put characters in there. New line, my input.eof. Is that correct? Sure. And then you're going to want the actual array literal, huh? Okay. And then instead of while character not that, I could say while not ending dot contains character. Do this. Okay, so if I have a set of characters, can I convert type character to expected argument type character? What is my type? Expected argument type character. Character's a character. Why would he contain? Okay, let's check out Swift set. Oh, I can just put it in braces. That sounds easier. Contains. Yeah, that seems okay. Ending of set of character. Can I do that? Okay, if that makes it happier, let's make sure everybody runs. Let's just pull this part. extract method, and this is skip until. I've got a sticky I key today, apparently. Skip until ending in set of characters. Wow. Okay. All right, let's move this down. And he's really down here, he's supporting level kind of stuff. So this is a good place. These I think are terminators is maybe the right name for them. It's just a local variable used once, but let's get it there. Okay, well, terminators. Well, we don't contain a terminator, skip forward. Okay, so skip until. I think that's cool. Where's that use? Okay, let's see if we can put this in here, inline this. And you can see this is our -- comments. They handle this input end of file. All right. I guess once the type was working, I should have trusted it. Okay. Same thing now. We're going to have skip until. And then our characters are dash, brace, and my input EOF. Nice. Okay. So I'm going to pop up to the top. So I seem to have a skip while. All these little while loops, I would like them to be pulled out. Okay, so well, let's extract this. Oops. Okay, come on. Refactor. Oh, you're not going to do it. Okay, let terminator equal space, and while the character, well, terminator is not the right word, is it? While match character. Okay. Let's extract this one. And this is skip while. On a character. So I think that's a reasonable one. Pull it down here. And then this can be a character. Okay. Skip until. If skip while. Well, we have a dash, character equals input dot next. Okay, digits. Okay, so digits is kind of like skip while, but it's skipping over a range. I wouldn't be too bothered. I don't think I would be too bothered if this had to list out the 10 digits. It would be nice if it didn't. All right, and I'm gonna move keep down. I kind of like to get things top down by default. Since digits comes before and calls keep, I think keep is a lower level thing. All right. We may not need keep in the long run. It's putting it in number, which is token. I can kind of live with that. It's a number in this case, but this is probably token. Let's rename it. And it's not clear to me we need to pass it in. Okay, let me just do it manually. Run those tests. What I'm looking to get is kind of like this one, that there's no while loops over the characters. One-offs is fine, like the E's and the pluses. Let's see. Let's change the sense of this. And I don't have a good refactoring for this. I'm gonna rename it is float to kind of get the positive sense. It starts out false. And if you see a dot or an E, it becomes true. And now if it's float, I'm going to return the float. Otherwise, return the int. Okay. This seemed like a compromise. I mean, we're tracking a little bit of stuff, but if you notice the prefix 0 through 9 plus, both integers and floats start that way. And we can't tell that it's no longer an integer and now it's a float until we see either that dot or the E. And once we do, we know it's a float. And at the end, we're gonna store it as a float. All right. I guess my safer way would have been to create a new set of variables, and so I had is int and is float kicking around at the same time. But all right, so we did several refactorings. Extract skip. Isn't that weird? Until skip while and miscellaneous minor touch-ups. Okay. Okay. I think that will do it for now. We can put a little more energy in, but I mentioned last time the complicated tokens. The two that are really the worst are these nestable comments and numbers, and everything else is pretty straightforward. We have names. Strings will be a little complicated, I guess, when we get there, but I think we are good. Okay. If let's see. So we've checked in. I think we're ready to move on. Is where we are. All right, so we've done a little bit of an interpreter. All right, let's get it here. This is it knows enough to handle numbers, integers, and floats, and prints their name or their value and their type. All right. Um, this, I think we want to get to the next step is to do Booleans. Now, well, the first step of that. Okay, let's take a look at them. All right, so in Elm land, let's find those literals, Booleans. Okay, so we did comments. Yay, we got through one section. We've done these two. We haven't done characters or strings. I'm going to put those off for a while. All right, but we do have Booleans. You got true and false of a Boolean type as if they were defined as a what do they call it? User type? A custom type. Okay. So a custom type, and we will start simple, but a custom type is you've got a type name and then you have some alternatives. And each alternative, like regular or visitor, sort of creates a new, almost like a constant. Or you can think of it as a function returning instances, maybe, kind of. But at any rate, it defines this value and it may have optional parameters. So in the example there, a regular visit, you have a user of two types. A regular person has a string, which is presumably their name, and I don't know what the int is. And a visitor has just a string. You don't have to have any types. So Boolean is type bool equals false or true. But we're getting into what does a type mean. So I think my starting guess is that a custom type is a set of alternatives that are the potential values of it. And I universally have seen capital letters for these types, like regular and visitor there, and for the type itself, user. So we're going to, well, let's try Elm REPL. We can do this. I'm gonna have to put new lines in it, or line markers. Yeah. Okay, so it's can't even find it. Okay, type user equals, well, let's just say FF or TT. Maybe this is my bool. Oh, one brace. Okay. Now if I say FF or TT. Okay. So I'm trying to do some, well, I guess inference on the way these types are represented, but I believe you get a type and it's got a set of I don't know what they're called. Values, maybe? Literals? Literal might be okay. A set of literals, each of that type. Okay, so we'll have to do some thinking on this, but we can at least get the tokenizing done. All right, so the token test, the lexical test. Okay, so if we have a uppercase name yields returns I guess if it's going to return a, what are we going to call this? Is it a type name? Is FF a type? No. It's let's call them literals for now. No. I mean, lowercase names show up too, right? So here's port prices is defined to be this is a function. The math goes from this to this to this. Do we have a better word in there? I mean, value. But I'm looking for the generic word that covers both the type name and the sort of literal name. And I may be wrong about the type stuff. Let's try that. Okay, so let's make type mybool2 equals FF or TT. Uppercase name. So it is requiring that. Well, uppercase name is going to be our default. Let's go with that. That's what they say they are. Let's take it at their word. All right. X is a token dot uppercase name. Okay, this will fail because we don't have a token like that. Expected parens in arguments. Let's go to token. Let's copy this. Go to token. Case uppercase name. All right. And the actuality, we really want the name in there. Okay, so just like the Elm one let us have visitor with their name and their int, our enums are very similar. And they almost are enums. In that sense, we need a string here, just like on our numbers. We have a float with the argument passed in. So let's do that. We get a free generated one. And this is just going to be a string. All right, now is our test good enough to fail? Let's see. Build and run. Oh, I left off a parenthesis somewhere. Oh, yes, I have. Okay. All right, so uppercase name X did not equal error. So as of now, our tokenizer doesn't know what to do with a capital letter. All right. It's 1:38 here, so we've been going a while. It's a good time to take a break. Got a red test, so we know exactly where to pick up when we get back. So 2 or 3 minutes, and we'll pick up from there, and I'll see you back shortly. Hey, welcome back. All right, even in that little bit of time, I thought of a couple things I want to do differently. I think the word uppercase we can use as a single word. And then I like to push the boundaries on things. So let's check the Z boundary in this case. All right. So Z, and our token needs to change too. All right, the test will still fail. All right. And in our case, we're going to do case A ... Z is return uppercase name. Okay. And we'll move the function down below the numbers. Right. And I don't know, I don't use these very much, but helper functions. The marks. Okay. Just to divide it out a little bit. Oh, this can go in there too. All right, so this is function uppercase name. Okay. And just like this one, we're just going to match. I mean, we know we come in with the Um, we've come in with an uppercase letter. Okay, so we just need to keep it. All right, and keep token. Just say address of token. Yes. So this thing of generalizing that so we can save it for these is definitely helping out. So we got our letter. Now there's no definition that I know. um, yeah, I mean, there's just not really a syntax definition. I can see it's got lowercase letters in it. Normally these names, you would expect them to hold, okay, there's numbers. Yeah, we expect that. Is that the only thing we can use? Let's try it out. Okay. Let's type my bool 2. Let's do f underscore 1 or f underscore 2. That's fine. What else do we get to use? Underscores, dollar signs sometimes show up. My bool dollar equals ff1 or ff2. No. Expected a lowercase name, equals sign. Okay, yeah. More letters in this name or white space. Okay, so I think we'll just assume underscores, digits, and letters. But I think for our purposes, well, if we return token dot uppercase name of token, string from the token, and this thing needs to return a token. Yeah, will that do it? Okay. One letter names are good. All right, let's check some. Test uppercase name with any letters or digits returns uppercase name. All right. Letters, digits, or underscore. Excuse me. All right, this should fail. Okay, and yeah, we only get the first letter. Okay. Now, we want to do a loop. So we need to allow one or more of any other letters. So, I mean, we're basically doing this with our letters that we're looking for. While 0.9, that's our range. Can I give that to a set? Well, let's do it this way. While A to Z excuse me, I'm just going to get through it. if A to Z or 0.9, I guess let's do characters first. A to Z dot contains character, or 0 to 9 contains character, or character equals underscore, then we're going to keep token. And what does keep do? It appends and grabs the next character. Sorry. It appends and grabs the next character. We got to make sure we're doing this right. Okay. It appends first, so we can actually use that to keep the first one because we know it starts with A to Z. Keep the letters while they're in one of the acceptable names. All right, let's see if this works. Should be. Okay, and then what would we like to do? I guess trying to think of a test for things that are not in there. Let's put a end of line comment. All right, so function test uppercase name stops when non-name character occurs. Okay, so, and I think we'll go back to check tokens so we can get that space. We can't use 9 because that is actually legal. So let's see, a ZB dash. Can I just put a bare character? What character would be completely unexpected and unuseful? I don't know. Well, this will do. Okay, and this is tokens dot spaces, and this is uppercase name with ZB, and it should pass. This should be confirming that our loop is already doing its thing, and we kind of know it is because we got an end of file. Maybe I should just let that be the case. Let's just let that be the case. So we'll check tokens, uppercase, and EOF. Again, this should pass. And I don't mind folding together test cases sometimes. You know, it already did its purpose of driving it out. And I'm testing a little more deeply and testing two things in effect. Okay, what else? Well, REPL. Okay, let's get crazy, right? We gotta find the limits of these things. What about weird symbols? Now, can I just get emoji? Sure, let's get good old smiley face. Slightly smiley face. Okay, let's take this. Put it in our REPL. Nope. How about A? Oh, interesting. My command line maybe. No, he doesn't seem to like it. Type a that equals X or Y. No. Okay, more letters. So he doesn't consider that a letter. What else is there letter-wise? Can I do a circle A? Not a default character. Letter like symbols. Nope. Okay. Cool. So we apparently don't have to worry about Unicode 2 too much. I mean, I haven't seen it in any of the stuff I've looked at, but I obviously haven't looked at everything. All right. Let's make sure everything's still running. Should be. But I know I inserted and took out a couple extra characters there, so. All right. So we have add an uppercase name token. Now, do we want to refactor this? How do we want to do this? I would really like to make a set of ranges that any of them contain it. Yeah, right. Let's see what we can do. Swift ranges with sets. No, that's just defining them. Range, integers, or other types. You can use it as in a for loop or with any sequence or collection method. So if you see what I'm doing, I'm trying to find a way to express this as one of my skip while or skip until kind of things. Now, I wouldn't mind giving it a set of ranges. And let's go back to range here. He should be a type variable, right? Range over some type, yep. Okay. Let's make a set. Okay, what are we going to do? We're going to make a set of ranges, and the goal is to go through each one of those. Okay, so let set be a set of range equals, and then I'm going to put each one of these. I think that's legit. Okay. And then cannot convert closed range to type range of bound. Range of character. Value of type closed range of string to expected type. range of character. Is it just this one that's creating the trouble? No. Value of closed range of string. Is that legal? No. Close range of character. State range of character. Well, is this a closed range? You're liking that, okay. From this to itself should be legal. Okay. Wow. So what we're going to do, so we're trying to say set dot, and there's a pipeline thing for this, I think. Form union all satisfy. There should be any satisfy. Is it some? Any? I'm hoping it'll have this in here, and then a neighbor contains where, first where, man, contains an element, sequence, first where is kind of close. I can't believe they don't have something that just has like an any satisfy kind of thing. Contains an element. I guess this is contains. It's going to be close enough. So we want to find out if the set contains where some function satisfies the predicate. Okay. So while set contains, and then we need a function Okay. And this is, the set is going to have a range. So $0 dot contains ch, I think is going to be the kind of thing we want to do. Okay. I mean, we're trying for refactoring here. Okay. So I'm trying to say I've got the set which has these ranges, and I want to say while, well, I'll just say it here. While set contains ch, do keep and token. And that's intended to replace this. While my set contains any range that contains the character, do that. Okay. All right. A little ugly getting there, but we're there. Okay, so now I want to extract this. Refactor extract method, and this is a I'll say keep while. All right, this should be okay. And then with luck, I can move this literal in. Take that out. Okay, so keep things while it's capital letters, lower letters, digits, or underscores. And I'm going to make this be A to Z, A to Z, A through Z, 0 through 9 underscore star. Okay. Again, I'm putting a little comment in to tell me what the grammar I'm matching is, but I think we're okay there. All right, so we made a keep while method. Okay, so I think our target, and this is I'm not sure where we're going here. I mean, I want to be able to say this. This would be a nice next step. True, Boolean. Okay. And this is a, what do we call that thing again? It's not a user-defined type. Custom type. Okay, so we want to handle a custom type object. I'm thinking Boolean is built in, so it's kind of a pre-populated one. And I think our set, well, our types, right now it's a very primitive thing, right? Our types are just simple Elm, a simple enum. All right, so let's look at interpreter or parser. No, AST, yeah. So here's the way types are now. I think we have a value and custom, maybe is it a custom value? Can we call it that? Okay. Let's see. So I don't know. We're gonna get. Oh, we got a bit under an hour here. I want to say there's some sort of Elm custom value that's. I think it's just a string. We may need to get more sophisticated, but. Let's start there. So there's an Elm custom value. It's got a name. No, that's probably not good enough. It's probably got to be deeper here. All right, well, the type, certainly there's number and float and custom type. All right, is going to have to happen. So let's find our parser. All right, so right now our expressions are very minimal, but I think what can happen is we're saying, just like you can type 42 and get 42 colon number, you should be able to type false and get false colon bool. All right. And that's an expression. I mean, it's kind of a low down expression, but you know, it's an expression. It's like, you might call it a factor, but at any rate, so my assertion is, if you give it false, if you parse the word false, it should come back with a token custom type, Elm Custom Type, no, Elm Custom Value, and it should have the attached name and a type. And maybe the type needs to be more sophisticated, but let's go there first. Okay. So let's get to a parser test. We really don't have parser tests, huh? Let's see. Character category. Yeah, that's just our extension. Interpreter. Well, let's make a parser test. Up till now, we've done the parsing and then just interpret it, and we expect a certain result back. Okay. I think we're gonna intervene and find out what these types are that get produced and check them. It's another stage. So, did I write this in our to-do at some point? Hey, you're supposed to be a to-do. No? Okay, let's do it this way. No, I don't think I really did. But, oh, here it is. Yeah. So we have a lexer. You give it a string. It produces a set of tokens, or a list of tokens. You give the parser a list of tokens, and it produces a tree. Actually, you give it a string, but it produces a tree that the interpreter then interprets. Okay, so the tree we're expecting is one leaf that looks like a custom value. Okay. And I'm not sure where we're going to find things. We are missing the notion of a symbol table, and that's going to start showing up. Okay, so I think what we want to do is take our parser. Right now, I think it's taking in inputs. Yeah, it takes inputs of strings, and it is responsible for converting it to tokens and using those. So let's make a parser test. And I think this is going to be more necessary. You know, with the simple ones, we can just interpret it and it's pretty much okay. But we'd like to verify the intermediate tree as well as the result of the whole thing. Okay, so this is parser tests. All right, and I'll just borrow the front of this. All right, okay. So the test we're going to make, well, we can probably make a check parse just like we had a check token. Okay, and I'm just going to borrow it. Okay, so so here's one of those. I'm doing it upside down from the concrete to the uses of it, because it's like, if you understand check token, you'll know what's going on in this file, hopefully. Okay, so check custom value. All right, so let's let parser equals parser of input. The expected is a tree, AST. And this is parser dot parse. Okay, so we would like to say check token. Our input string is false. And we expect AST. Well, it's going to be Elm Custom Value. We'll give it some stuff in a minute. But at any rate, we expect an Elm Custom Value with, I guess I'm going to give it this, and the type is, what is the type? Well, it's going to be some sort of custom type. So you can see I'm minimal at this point. I may have to say AST Elm Custom Value Elm Types Custom Type. Okay, I know I want to attach stuff. AST has no member Elm Custom Value. Elm Types has no Elm Custom Type. Elm Custom Value. And I guess like them, I'm saying there's a value. For now, a string and a type of Elm Types. Okay. And that should fail. Hopefully for the right reasons, but yes, it should fail. AST has no member Elm Custom Value. Oh, our exhaustive switch. We're going to go to the default. All right, just to get my switch exhaustive. Can only appear inside a switch statement. That's not a good format, thanks. Okay. This is probably just a compiler thing. Oh, we don't need the Elm. All right, now let's get a good honest fail. Okay. How about test custom value? All right, that's what I want to see. Expected custom value false. We got Elm ignored. All right. So we got a failing test. It's a good time for another break. Let's take a 2-minute break and we'll come back and I think we'll get it working, but we got some work to do beyond that. It needs more sophisticated knowledge of the types and we'll have to make it go. So see you in a bit. Hello, welcome back. All right, so we've got this token false. Let's call this check parse. Okay, check parse. We're giving it the string false, and we expect to get back a custom value false, and it's going to have a custom type. All right, I know that's not as fancy as we want, but let's get going. Where's our parser? Somehow I get lexer twice. Doesn't seem fair. And our parser. Okay, so we've got parse. What do you do when you get a token, a float, or an uppercase name? I think I can just do it like this. Okay. And we want to do expression. If we see a token dot uppercase name with value, okay, let's maybe call this name. All right, if we saw that, we want an AST dot custom value with the name, and the type is going to be Elm types dot custom type. Now, I think this will pass, but it's not really good enough. But let's get it as far as we can. All right, so succeeded. Good. Let's push this test. Start to handle custom types. Okay, now I'm going to get more sophisticated. My custom type. Well, oh boy. I mean, what's a custom type? It's gonna be, well, what does it consist of? It's either gonna, well, it's certainly got the name of the type, and somehow it knows the names of the values. And I don't know, I think there's another object kicking around, right, that contains those things. But maybe not. Maybe it's, what would be enough? Well, let's work on our test. So I would expect a custom type whose name is bool and whose values are false and true. Okay. And somewhere this is a built-in kind of thing. So that's kind of interesting. But Elm Custom Type, and you know, these arguments probably could be a separate type, but let's start simple. Okay, so Custom Type, and it's got a type name of type string, and it's got values of type array of string. Maybe that set of string. All right. And then Elm types is not conform to equatable. Presumably, add protocol stubs. Yeah, well, that's extension AST is equatable. It's happy to do simple comparisons of types, but once you get nested things like this, it's not so happy to compare them. Okay. But our code is we've got LHS and RHS. Okay. So I think we're going to have to just do a big switch again. Switch LHS. Well, I can do this, right? Switch, look at the paired stuff. I think I do it like this. Yeah, put up in parentheses. Well, if they're both that's true. That's fine. Okay. Next case, integer. Okay. This I wonder about. It seems to be what it does. Okay. Elm custom value let matching him as a tuple is deprecated. Oh no. Oh no. Okay, so much for the easy way. Do I just switch on the LHS, I guess? Ugh. Okay, calculus Elm ignored. Return RHS equals Elm ignored. Can I do that? And these are going to spread out a bit more. In enum case, Elm integer has two values. what the issue is. Let's keep going. Okay, if let let's comment this out a moment. Sorry about the phone in the background there. Sorry, if I let I'm going to have to find an example, I think. Switch enum example. These are primitive. Yeah, I want ones that have values in them. Case dot in value. Let the values. Okay. Two lets, yeah. Value 1, type 1. Case let. The value comes after the operator. Okay. Okay, we got two values. Oh, come on. Without more context, I've got RHS of AST. this should be Elm Manager. Cannot be applied to types. Okay, we're getting buried here. Okay, but if they're not equal, they're false if the types don't match. Okay, and extension Elm types is equatable as well. Okay. Oh, it's not complaining yet. Interesting. Okay, let's get the next case. .elm float. Let value 1. Let type 1. I don't know if this is legal. That, and otherwise return false. I'm just trying to get the same stuff I got for free a minute ago, but now I've got a bigger type and I can't accept it. So I don't know if this will compile. Elm types conform to hashable. Oh, that's some type has no cases, has no values, so we're still compiling it. Dictionary requires Elm types conforms to hashable. Boy, it sure didn't look like I was making that big a change to Elm types, did it? All right, let's, where did my thing go? Oh, there we go. Can I say this? Just trying to get through the compiler at this point. Must have at least one argument of type Elm types. No. Oh, yes. Elm types. I guess I'm supposed to be defining this, so it's not going to take it. that legit? Okay. We haven't got to the hashable thing yet. Dictionary. Okay. I don't know. We're going down a path here, aren't we? Okay. Well, let's get this last one. Case. We'll turn false for the moment. Get this thing going. I think these should be. That. Mutable value default will never be executed. Yeah, I'm fine with that. Cannot convert. Elm Custom Value. Okay. What are we saying here? Cannot. Dictionary requires Elm form to conform to hashable. Yes. Okay. Now, hopefully it'll prompt me. Hashable is definitely different than Java's. I don't remember how it works, but I think, let's see. I'll have to find an example. Yeah, we need a hasher. I definitely have not done Swift hashable enum. Yeah, do I have to pick out all these things? Oh, I can just provide hash value? Okay, well, that's easier. Okay, well, I guess That was good while it lasted, but you got to do this. Can I switch on myself? Yeah. Sorry. Switch self. Okay. Case.number dot float. Can I just put anything? Hoping that one goes. Okay, if we just combine some arbitrary number, otherwise custom type, we're going to combine the two values. That's a plausible hasher. Let's build. Cannot convert Elm types custom type to Elm types with arguments. Yes, that's custom type. Let's put this for, let's put a question mark. For now. Okay. Custom type bool. This one compiles with it. The other one complains it doesn't have it. I don't think it's a case of... Okay. Bad access. Type equals something infinite. Oh, infix. Okay. Well, we may have to stack our parser test for a moment. Apparently my AST off the cuff did not work. Although this is... Where do we actually die? Well, this is suspiciously deep, isn't it? One would almost say infinitely deep. Okay. So I think we're calling this effectively, but I don't know how to. Testing value Swift. Well, yes, that's the kind of question I've got. It will automatically add a equatable. We already know this syntax is not going to fly. Yeah, no compiler generated quality. Yeah, I guess I can nest them. Oof. That's not helpful. Not without digging. Yeah, I guess a nested switch has got to be the way to go. Okay. Is that as compact as I can get, I guess? Case RHS. Oops. Stop this. Okay. Yeah, that's. Borrow that out for a minute and let's try again. I wanted to fail because they come out not equal, and then we can. Oh, but we don't even have that test anymore I commented about. Okay, let's try this again. You're not going to go infinite on me again, are you? Okay. Elm custom value false and custom type Boolean with the set false true is not equal to question mark stuff. Okay, that's progress. Let's at least get the comparisons working correctly here. So I'm going to do this switch RHS thing. Case.custom type, let type 2, let values 2. Return type 1 equals type 2 and values 1 equals values 2. Default return false. I feel like there's got to be a way to do this better, but okay, so we want this to be more strict. We don't parse it correctly at all, but we want to get the reason it fails showing up the right way in the next 3 minutes. Okay. And then this one also, well, I guess the case let is kind of the equivalent of the switch case thing. So I don't know. Is this more readable? Elm, whoops. Otherwise, return false. And I know we should just pick a syntax, but I'm going to let it bubble for a while. It was nicer when it synthesized it. Should still fail. Okay. I think for the same reason, but it's just it's coming out a little more accurately. Okay, so false, bool, set false true. Like we never have that anywhere in our stuff. Not equal to custom value false. The first part's okay, but this we just made up a default answer. Okay, so I think that's going to be where we stop today. Tomorrow morning, 9 to 11:30 a.m. Eastern time, we'll pick up again. I think what we'll have to do is basically define these custom types out and then seed in sort of the default ones. This is the very primitive part of setting up our initial state of things to have the system built-ins. I think if we do that, we will be able to get this thing going at least and see what we got to do from there. I don't think it's as encapsulated as it needs to be. Like Elm Custom Type probably should just have a object that represents a type of some sort. And then we can just pre-populate those. But this will get us moving. And I'll see you tomorrow, I hope, or sometime in the future. Take care. Bye-bye.